So on this problem, we're supposed to evaluate this improper integral, see if it's convergent or not. With evaluating from 2 to infinity, when I get this, sometimes that seems a little bit more complicated. So one of the things I might do is just forget about the limits for a minute, and let's just look at the integral of 8 over x natural log of x dx. And let's just forget about the fact that we have from 2 to infinity, and just work on the integral for a minute. Okay, let's see. When I look at this, it seems pretty complicated. But one of the things I think is, if I was to take the derivative of natural log of x, I'll get 1 over x. So that seems like maybe I should do u substitution. So I'm going to do a u equals natural log of x. And then the derivative of u with respect to x would be 1 over x. Or the derivative of u is 1 over x times dx. So coming back over here, this natural log of x, that will be u. And if I take the x and the dx together, the 1 over x specifically, and dx, that gives me du. So I think we're set up to do u substitution here. And let's rewrite this and see what we get. So we have the integral. The 8 is just kind of floating there. We didn't do anything with the 8. But 1 over x and dx together give me du. And this is, u is this natural log of x, so we have 1 over u. And I would prefer to write this as 8 times u to the negative 1 du. Okay, and so when I integrate this, the 8 just stays there. Now u to the negative 1, we would add, excuse me. I was going to add 1 to that, but then I get u to the 0, and that doesn't really make sense. And then I remember, coming back to this step, if I'm trying to integrate 1 over u, the integral of 1 over u is natural log of u. Forgot all about that. Okay, so we actually have now 8 times natural log of u. And instead of having u's, let's go ahead and plug our x's back in, which is natural log of x. So we have 8 times the natural log of the natural log of x, which might seem weird, but is perfectly okay. So now coming back to our original problem, we wanted to take the integral from 2 to infinity. So let's say we want to evaluate now this from x equals 2 to infinity. Now back here, because we did u substitution, I could change my limits to limits of u equals, but I actually kind of prefer to just stick my x's back in and just keep using my x limits. So you notice here, I didn't change my limits, and that's perfectly okay as long as I'm plugging x equals into x's and not into u's. Okay, now at this point, you should technically write it all out officially, like do a b here and do the limit as b goes towards infinity and everything. But sometimes I don't even bother with that. Sometimes I'll just plug the infinity straight in. So we're going to have 8 times the natural log of infinity minus 8 times the natural log of 2. Now this is technically the limit as b goes towards infinity. So we're technically doing a limit, but I just kind of write it in here. And then I think, what does happen if you have the natural log of infinity? So the natural log of infinity slowly goes to infinity. It's much slower. It doesn't get to infinity as quickly, but it does go towards infinity. And even taking the natural log again, it should still be going towards infinity. So this part just goes to infinity. So infinity minus any number is just going to be infinity. And so because we don't get a specific number, but we get infinity, we'd say that this interval diverges, because